we just want to continue talking about permutations. We talked about the fact that permutations are telling you how many ways you can pick a group of R, we called it, objects from a group of N total. And we said that with permutations, order is very important. And so what we're going to talk about is what happens when you want to get a set of N objects with A, that is A being just some letter, of one-of-a-kind objects, and B of another kind of object, and C of another kind of object. So what happens when there's repetition in the objects we're talking about, okay? And what we mean by that is, for example, if I just took the word mathematics, okay, so let me just write it down here and I'll show you what this means, okay? So we have, actually let's do something a little bit smaller. We'll just do math magic, okay? So this is a new term I've coined, math magic. But imagine I want to say how many ways can I rearrange these letters? So what we're saying is there's, first of all, 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. So N is 9 because there's 9 total letters. And then what we do is we say, okay, how many letters repeat? So there's M and M, so there's 2 M's. Okay, so we call that A, and we say that's going to be 2 factorial on the bottom. There's 2 A's. We're going to call that B, and we'll say that's also 2 factorial because there's 2 of them. And then there's no other repetition, right? There's 2 A's, there's 2 M's, but everything else is single. So what we're saying is the number of ways that I can rearrange these letters is going to be 9 factorial divided by 2 factorial times 2 factorial, all right? So that's my total number of letters, that's my repeating A's, and that's my repeating M's. And so 9 factorial becomes 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And on the bottom, 2 factorial is 2 times 1, and then we're multiplying that by 2 times 1. So what ends up happening is 2 and 2 makes 4, so we can get rid of that, and we just have to figure out what 9 times 8 times 7 times 6 times 5 times 3 times 2 times 1 is. So if I grab my calculator here, it should be able to tell me. Most calculators have a factorial button. I happen to have one here, so what I'm going to do is I'm going to take 9 and just hit factorial, and it's going to tell me all of them, and then I'm going to divide it by 4. And it's going to be 90,720, so I'm going to write that down here. Okay. So there's lots of different ways to do that. If you look at example 3 in your textbook on page 521, it says, how many different 8-letter arrangements can you make using the letters of aardvark? And so what you have to do, first of all, is say how many letters are there total. So 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 total letters. So that's N. And then there are 3 A's and there's 2 R's. So we end up with 3 A's, 2 R's, and 8 letters. It's 8 factorial divided by 3 factorial times 2 factorial. And what I'm going to suggest to you is the easiest way to do that instead of writing it all out, which you should be able to do because you should understand how factorials work. But the easiest way to write it out is just go on your calculator, say 8 factorial, and then we're going to divide that by 3 factorial, and then we're going to divide it by 2 factorial. Okay, and we end up with 3,360 ways to do that. Okay, if you look at the second example, second part of the example, right, it says how many paths can you follow from A to B in a 4x6 rectangular grid if you move only up or to the right? Okay, so you can go, okay, just move this over slightly, B's right here. So essentially you have to move over 1, 2, 3, 4, 5, 6, and you have to go up 1, 2, 3, 4, right? That's what you have to do. So there's 10 different ways that you can do that, total of 6 and 4, but 4 of them repeat and 6 of them repeat. There's 6 rights and 4 ups. There's a total of 10 moves, if that makes sense. So it's 10 factorial divided by 4 factorial times 6 factorial, because you have to go over 6 times, you have to go right 6 times, and you have to go up 4 times. And you basically, you can go up, 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 right, 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 or you can go right, up, 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 right, 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 up, for example. So there's lots of different ways you can rearrange them, but we're essentially saying, how do you rearrange this pattern? Okay, so that's the idea of permutations with repetition. And there's other questions there. If you look at the example on page 522, it says this: 5 people, A, B, C, and D, A, B, C, D, and E, are seated on a bench, and how many ways can they be rearranged if E is seated in the middle? So there's a couple of different ways to approach this question. The first way is to say, okay, if E is in the middle, there's E. There's only one way to do that. Once you have E in the middle, then you say, well, how many other people are there? There's A, B, C, and D. So there's 4 options here, there's 3 options here, there's 2 options here, and there's 1 option here. So it's 4 times 3 times 1 times 2 times 1, which gives you 24. All right. If you look at the next one, it says, imagine that A and B are seated together. So what you do with that is say, okay, if A and B are together, then there's basically 4 blocks, right? A, B is considered a single unit, so it's one thing. But they could be A, B, or BE, or sorry, BA. In other words, they could be rearranged as AB during that block, or they could be BA, and then C, D, and E are left over. So what we do is we take, in each case, the options are 4 factorial, right? Because there's 4 things. So there's 4 factorial there, that gives me 12, right? 4 times 3 times 2 times 1. And there's 4 factorial here, which gives me 12 again. Sorry, not 12, 24. Forgot to multiply by 2. 4 times 3 is 12, times 2 is 24. So there's 24 and 24, and then we add those together, and we end up with 48 total. All right? So there's 48 ways to do that. Because of this, inside the A and B, there's 2 ways to do that, and for each of the other arrangements. Okay? So that's the idea behind permutations with repetition. All right, and then what we want to do is we want to just talk about combinations briefly. Combinations are similar to permutations, but all they're doing is they're removing the repetition. Okay, so a combination is a selection of objects, but order doesn't matter. So I don't care whether the things that I pick are ordered. All right, and the notation is this, and you'll notice that this n factorial and n minus r factorial, that is the permutation, right? That is the formula for the permutation, that's NPR. And all we're doing is we're dividing by r factorial. And essentially what we're doing is we're removing the repetition. So if you think about one of the questions we did earlier with permutations, we said that they have to be selected for a student council, for example. So we said that there's 4 positions. So we're picking a group of 4 from 20. And we said that matters because they're going to be president, vice president, treasurer, or secretary. And those are all different. With a combination, we're just saying, just pick 4 people. So if we pick 4 people, and let's say person A is picked first or second or third or fourth, that's 4 different ways to pick a group of 4, but they're actually all the same because that person is in the group. So what we would do is we would say, we're still going to do 20 factorial, and we're still going to do 20 minus 4 factorial. That's how we did it with permutations. But all we're saying now is, but there's 4 factorial ways to arrange that group, and we're going to get rid of them because they're essentially the same. So we're just removing repetition with combinations. Okay. And again, you don't have to know how to use the formula in terms of writing it all out as much. You do have to know it for some of the questions you're going to be asked to do. So I'm not saying don't know the formula, but you can also find that on your calculator. There is an NCR button as well. And so your biggest job is going to be, once you know the question is either a permutation or a combination. In other words, it doesn't say just do these as permutations or do these as combinations, but you have to pick. Your biggest job is going to be to figure out, is order important? So when you read a question, you're going to have to say, okay, I know I have to count the number of ways I can do something, but is it a matter of order, or is it a matter of I don't care about the order? All right. So we're going to look at a couple of examples. If you look on page 530 of your textbook, let me just jump there. Okay, then you will see, if I can, down here. Here's the question. It says there are 12 females and 18 males in a grade 12 class, and the principal wishes to meet with a group of 5 students to discuss graduation. So the question is, how many selections are possible? All right. And the interesting thing about the first part of this question is there's no stipulation that there has to be so many females or so many males. So how many total people can they pick from? It says there's 12 and 18. So if you add 12 and 18 together, you have a total of 30. Okay. So the first part of this we're going to say is 30, and we're going to choose 5 because we don't care about order. And the reason we don't care about order is where they're not getting selected for positions. They're just getting selected as a group. So we do 30 factorial divided by 30 minus 5 factorial times 5 factorial. And if you work that out on your calculator, you can do it that way pretty easily, or you can actually go, okay, 30 factorial, and we did some of this with the permutations video. It's 30 times 28 times 29 times 27 times 26, and then times 25 factorial. So actually the last large portion of that just cancels. So 25 factorial goes away, and I end up with that. Okay. Either way, you can use your calculator right away, or you can do it out like this, but there's a lot of ways you can do that. So that's how you use a combination. But then the question says, how many selections are possible if the group consists of 2 males and two females and 3 males? So here, what you have to do is you have to change how you're doing this. And I'm going to hurry through this because I'm running out of time, but you have to pick the females. There's 12, choose 2 of them because there's 12 females to pick from, you want 2. And the males, there's 18 males to pick from, and you want 3 of them. And then you're going to just multiply that together, okay? And it ends up being a fairly large number. So that's the idea behind combinations. There's more to it. You'll get to practice more, but a combination and permutation are very similar. The combination is just order doesn't matter. So we're going to leave it there, and we'll do some practice.